Imagine standing on the polar ice sheets under a dome of endless stars. Snow crunches beneath your boots, the wind bites your cheeks, and the cold seeps into your bones. But there in the middle of the snow, you see something impossible, something that defies belief. A chunk of ice, raw, pure, and glacial, is burning. Flickering flames in ghostly blues and whites, licking at the frozen surface without melting it. You step closer, your breath visible in the frigid air, and one thought dominates your mind. How can ice burn? Welcome to one of nature's strangest and most captivating phenomena, the burning ice. A paradox of fire and frost where extreme opposites meet, coexist, and leave us wondering if nature is hiding a secret we've yet to fully grasp. This is the mystery of ice that burns, and today we're going to uncover its secrets. To understand this phenomenon, let's start by traveling to one of the coldest and most remote places on Earth, the Siberian tundra. Beneath the frozen lakes and permafrost of these Arctic regions lies an astonishing material, a substance both ordinary and extraordinary. It's called methane hydrate, or, more poetically, fire ice. At first glance, it looks like the kind of ice you might cube and toss in a drink, but methane hydrate holds a secret that distinguishes it from regular ice cubes. This particular crystalline structure of ice has trapped methane gas, one of nature's most flammable substances, inside its intricate lattice of water molecules. Now here's where the magic begins. Methane hydrate is stable only under extremely cold conditions and immense pressure, like those found deep beneath the ocean floor or buried in frozen tundra. But when you pull it out of its natural environment, say you scoop it up and bring it to the surface, the balance is disrupted. The ice starts to slowly release the trapped methane gas. And if you happen to ignite it, something incredible happens. The methane catches fire, creating those ghostly blue flames. The ice itself doesn't burn, of course. What you're seeing is the gas blazing away while the frozen shell remains intact, at least until the heat melts it. So what seems like burning ice is actually a spectacular display of chemistry, fire fueled by methane emanating from its chilly prison. But methane hydrate isn't just a neat trick or a party trick for Arctic explorers. It's also one of the most enigmatic substances on Earth, with the potential to transform our understanding of energy, climate, and even the future of humanity. Methane hydrate is found in such abundance that it's estimated to hold more energy than all the world's known reserves of oil, coal, and natural gas combined. Let's pause for a second to think about that. Entire oceans and tundras are hiding vast reservoirs of this combustible ice, just waiting to be discovered and, potentially, harnessed. Some even call it the energy of the future. If we could safely extract methane hydrate without damaging our delicate ecosystems, it might just be the key to sustaining our ever-growing demand for energy. But, as always, nature doesn't like to make things simple. While methane hydrate appears to hold promise, it also carries risks, big ones. Methane is a potent greenhouse gas, far more effective at trapping heat than carbon dioxide. If we accidentally destabilize large deposits of hydrate, we could release massive amounts of methane into our atmosphere, accelerating climate change in ways we can barely comprehend. It's like walking a tightrope. The potential rewards are immense, but one misstep could lead to disaster. Burning ice suddenly seems a lot heavier than it looks, doesn't it? And the mysteries don't stop there. Scientists still struggle to fully understand methane hydrate. It forms spontaneously under the right pressure and temperature, almost like some ghostly alchemy, and yet its precise behavior remains unpredictable. For example, how did so much methane become trapped in ice in the first place? Was it a result of ancient organic material breaking down beneath the sediments of an ancient ocean? And could there be other planets or moons like Jupiter's Europa or Saturn's Enceladus, where similar processes create vast reserves of burning ice waiting to be unlocked? These questions make methane hydrate not just an earthly curiosity, but a cosmic mystery, possibly linking the origins of life on Earth to the potential for life elsewhere in the universe. The story of burning ice also carries a haunting reminder of our delicate relationship with the natural world. Some scientists believe this substance may have played a role in past mass extinctions. Imagine entire reservoirs of methane hydrates suddenly destabilizing, perhaps triggered by underwater landslides or volcanic activity. The released methane would spike global temperatures, unleashing cascading changes to ecosystems far and wide, a devastating chain reaction locked beneath oceans and tundras. And yet, it is this same substance, this volatile union of fire and frost, that holds hope for our future. If harnessed responsibly, it could revolutionize clean energy. The trick lies in finding a way to use the methane without triggering environmental catastrophes, an epic challenge for scientists, engineers, and policymakers alike. So here we are again, standing in the frozen expanse, gazing into the ghostly flames dancing across a cube of burning ice. It's a reminder of the paradoxes that nature loves to throw at us. How something as cold and lifeless as ice can hold the fiery essence of energy within it. It's also a reminder of our own human ingenuity, that our drive to understand and harness the elements around us has shaped our story since the dawn of time. Next time you picture ice, think beyond your frosted drink or a winter morning. Think of the depths of the Siberian tundra, the ocean floors, or even distant moons, where ice burns with an almost mythical glow. The mystery of burning ice isn't just about fire meeting frost. It's about how nature continually challenges us, with its contrasts, its wonders, and its secrets tucked beneath layers of cold. It beckons us to question, to learn, and to never stop exploring. Because the more we discover, the more we realize, nature's greatest mysteries are just the tip of the iceberg.